this is our regular hyperbola here. This is what it looks like. Now, this is obviously a very unique graph. It looks nothing like the graphs that we've done before. So let's talk about the graph that we're looking at. So we've got two parts. We've got one that's on this side and this side down here. So coming back to when you first would have done Cartesian planes, you had the 4 quadrants. So these 2 quadrants are the ones that contain the graph when it's unreflected, untranslated, undilated. Obviously that can change, and we will go through how it changes. Now, when we first did exponential functions, that did contain asymptotes. This doesn't just have one asymptote, it has 2. It has this vertical asymptote, which, remember, any vertical line has the equation x equals, and in this case 0 because it's along the axis. And then we also have a horizontal asymptote, which has the equation y equals 0. So as you can see, we have 2 asymptotes. When I do these graphs, I always find it the easiest to draw my asymptotes in first, just to make things a bit clearer about where my graph is going and what lines I cannot cross. Now, we have the x on the bottom. Of the fraction, and that's what makes this different from, say, our normal linear graph, because coming back to our indices, if we were to make this into a normal number, this would be x to the power of -1, which is what makes it look like this, and what retrieves us those 2 graphs, because it has that negative power. Now, the number on the top here where we have a 1, this is our regular graph, 1 over x, no translation, no dilation, no reflection, nothing. This is our standard graph. However, if it was going to have a dilation, it would be on top. So instead of the 1 on top, we would have a bigger number to dilate the graph further out, and I will show you that in a second. We can also move the graph left and right and up and down. Now, just for this Jack Plus chapter, you will only be doing the left and right translation. You will not be moving the graph up and down. You will be doing that next year in methods if you so choose, but for this year we're just moving the graph left and right, and we're dilating it and reflecting it. Okay, so the general form is this when we're looking at it. We call k the dilation, so k is the number on top. X is always on the bottom for these graphs, because that is our standard equation. So k is our dilation factor. So looking at our dilation, the blue graph is our normal graph. That's our normal 1 over x that we're looking at. Now, as you can see here where I've got this next graph, where I've got my second f of 2x, which is just y, I've got 5 as the dilation factor on top. Now, if you follow this graph along, as you can see, it's pushed it out further. It sort of pulled it away from the origin, and that's what a dilation factor in this case is going to do. It's going to pull it away from the origin. So we can see that the blue graph comes in quite nicely to the origin, and then when we get to that red graph, our second graph, we're pulling it away, which is the effect of our dilation factor. Now, we can also reflect our hyperbola. So our normal hyperbolas are in the bottom left and the top right. As we can see from the blue graph now, if we reflect it, so as in I've got this negative at the top, that's when it flips around. So instead of being in the bottom left and the top right, I'm going in the top left and bottom right direction. Now, if you think about it, sort of makes sense, because remember, a positive gradient goes this way and then a negative gradient goes this way. And that's the line that our reflection is following. So because it is negative, it goes top left to bottom right. Do I have any questions so far about dilation or reflection? Okay, not yet, but remember, yes, Alex. Yes, yeah, I am coming to the example, Alex, don't worry. Okay, so horizontal translations, the last one we're going to do, you just have 3 for this one. So for this one, our red graph is the normal graph, our 1 over x graph. No dilation, translation, reflection, nothing. With our blue graph this time, we have this +2. So remembering that when we do a quadratic, say when you have something like x plus 2 squared, this moves the graph left. And remember how I said it's kind of confusing because you think it would move it right, but it doesn't. It moves it left. So I always think about it as going the opposite way to what I naturally think it would move in. A +2 moves it left 2. Now, the interesting thing about this is that it also moves the asymptote. So the one that stays the same is the y, because remember, I'm not moving the graph up, so my y equals 0 is staying the same. So you can see both my blue and red graphs don't cross the y equals 0 asymptote. But my normal graph has the asymptote at x equals 0, because remember the vertical ones are x equals, but my blue graph has moved over. My blue graph's asymptote is x equals -2. So if it's moved left 2 units, my x asymptote is going to be at -2. So whatever this number is on the bottom, it'll be the opposite sign and x equals that number. So let's put that into practice with a few examples, and I do have an example of each one, so don't worry. Okay, so I need to plot the graph of y equals x. So drawing my axis. Now, as I said, I always like to put in my asymptotes first. Sorry, I'm just flipping my laptop to make life easy for me. Okay, so asymptotes first. Now, I haven't moved my graph left or right, so no horizontal translation. So because of this, I can keep my asymptotes at y equals 0 and x equals 0. So if you have no horizontal translation, and by that I mean this x plus 2 situation on the bottom, you haven't moved the graph left or right or up or down, so your asymptotes are staying at 0. X equals 0 and y equals 0. Now, this graph is also, it doesn't have a negative, which means that it is positive, so it's going to come down this way and this way, and I would appreciate the arrows. Now, similar to when you're drawing your exponential functions, please make sure that you're not crossing the asymptotes. I don't really care if you are a little bit further from them. I would rather you be further from the asymptote than accidentally cross it. I just really want you to show me that you know it shouldn't cross. So you're drawing sort of like a curved L shape in the top right and a curved, a flipped L shape on the bottom here. So we're just following this shape. And we know it's in the bottom left and top right because we don't have a negative, so it's positive and it follows this trend up here. Now, the dilation of 4, it does make it wider. However, when I don't have another graph to compare it to, it's pretty much you're following the points if you are given some, but it would be wider than our normal graph. So if this is my y equals 4 over x graph, if I was to draw in my normal y equals 1 over x graph, that would come down here. So as you can see, my blue graph is further away from the origin on both sides, and that's because of the 4 on top. It pulls it away. Questions about this particular example? Okay, so our next example, we have the 3 on top. So the dilation factor of 3. So I'm going to be a little bit further away from the origin than a normal graph. I also have this negative here, which tells me that it's going to be reflected. And then I don't have a translation. So I'm not moving left or right. So because I'm not moving left or right, remembering that that means all my asymptotes are at 0. So my y equals 0 asymptote and my x equals 0 asymptote. Now, dilation factor of 3, so I'm moving a little bit further away from the origin, and I've got that negative, so it's reflected. So instead of being down here and up in the top right, I'm going to be drawing my graph this way and this way. And again, this is because of the negative that has reflected my graph. Okay, and our last example. So looking at my top number first, I have no dilation, so I'm coming closer to the origin, and no reflection because there's no negative out the front. This -2 that's here, this is going to move my graph to the right by 2 units. So because it's x minus 2 this time, it moves to the right, remembering that our example... Yes, yeah, go for it. Yes. Great question. So Alex is asking what if it looked like this? So this number on the side would give a vertical translation, so it would move up or down. We're not focusing on that this year. You will be doing that next year in methods. For now, we're just doing the horizontal translation, but great question, Alex. Okay, so we're moving 2 units to the right. So drawing my axis. Okay, now, as I said, we're not moving up or down. So my horizontal asymptote is always going to be at y equals 0. However, I have moved my graph 2 units to the right. So my asymptote is going to also be moving 2 units to the right, and it's going to sit at x equals 2, positive 2, because I've moved to the right. So as you'll notice with this graph, I'm drawing my asymptotes first, so you can get an idea of where to put your lines. People that do it the other way around confuse me. I don't get it. I need the guide of the asymptotes. So I always draw them first, and then your second step is to draw your graph. So I don't have a reflection, which means it's still going to be the standard bottom left and top right. So my graph is going to come down this way and up this way. Okay, so that was our last example for this chapter. Do we have any questions before we get started?